Hey, Mr. Kern here. This is lesson 25 and 26, looking at types of bonds. In particular, we just did the lab where we are seeing if things conduct and dissolve. So we'll look at why different substances will conduct electricity and why different ones will dissolve. So first off, we'll kind of start by looking through the sheet that you did, looking at the questions. If you haven't already answered them, you should answer them now. Pause it and then answer them, then check back here while we talk about them, because then it'll be you getting a lot more out of it instead of me telling you the answers. So when you're done, unpause it and keep going. So they have you start off by organizing these and on which ones dissolve and which ones don't. So we can do that real quick. Wax did not dissolve, sand did not, salt did, ethanol, or sorry, grab that one. Copper did, sugar, or yeah, copper didn't, sugar did, ethanol did, aluminum did not, calcium chloride did. You may have had didn't because that one, water can't take very much of that, and it gets saturated, it gets too full. So you might have put a little bit in and it dissolved, but then the rest of it you put in just sat at the bottom. So sometimes it's hard to tell. So you can check and make sure your answers match up with these before you go on and look at the rest of them also. So questions on there, things that conduct electricity but didn't dissolve. So looking at these, we have the ones that conduct and that don't. So the two that conducted were the copper and the aluminum. The two that didn't conduct were the wax and the sand. So those live on that side. On the other hand, with these, we had the ones that don't conduct and the ones that do conduct. So water, the pure water, does not conduct. The tap water did. So we'll talk about what that means. Salt conducted, sugar didn't. Ethanol did not. And your calcium chloride and copper sulfate did. So just in organizing these, now you're able to look at trends and we'll figure out why some things conduct and why some things don't. So looking at the ones that conduct electricity when they're not dissolved, those guys are metals, which, again, that should be really evident that those are going to conduct and not dissolve. Looking at like what these guys have in common. I'm kind of going off the questions a little bit. It'll all get in there, information-wise. If you're looking for these and what they have in common, a lot of the key to this is looking at where these live on the periodic table. If you look at salt, sodium chloride, you have sodium and chlorine. You have calcium and chlorine. You have copper and sulfate, that's the S and the O. So if you're paying attention to where the metals and the non-metals live, all of these have a metal and a non-metal or an ion. And so these are the ones we just got done working with, the ionic bonds. So that's apparently kind of the key to that type of quality. It will dissolve, it will dissolve and conduct. That's what the ionic bonds do. It's a metal plus a non-metal. So it's one thing those guys have in common. You may have different things that you find in common. Somebody had one earlier, like I have never thought of this, a way of looking at it, but it was pretty good and correct. I don't remember what it was. It was good. Alright, so looking at these, what these have in common compared to these. Now there are a lot of similarities. You're looking at H's and O's and C's and an SI. So if we look at the table, hydrogen, oxygen, carbon, and then we had an SI. So hydrogen, even though it lives over here, it acts like it lives over here. It is a non-metal. So that's what a lot of these have in common, are non-metals. Silicon's a metalloid, so it has some qualities of both. But overall, both of these are just non-metals fitting together. So that's the characteristics that are really significant in those. You have nonmetals, whereas the ones that conduct are metals or have some metal in them. Now, none of these conducted dry. It was only the metals that conducted dry. So hopefully your results match mine, otherwise it's kind of hard to analyze these very well. Now, if you're looking at the difference between these molecules and these formulas, it's kind of tough. So you have to know a little bit more about the structure of what's going on. So we'll have to look into that a little bit more. So if we're writing a statement overall about things that do light up the bulb, the ones that do light up the bulb, we could say it has a metal in it somewhere. That's about the only thing these have in common. The ones that don't light up the bulb, they're all made out of nonmetals. That's about all that they have in common too. Prediction. So number 7 on the worksheet, isopropanol. So C3H8O. Do we think that will dissolve? Well, they say it's a liquid. Those, let's see, you had water, you had ethanol, they dissolve. Isopropyl alcohol is also an alcohol. I would guess that it would dissolve, but whether it will conduct, it would be a definite no, because it's all made out of nonmetals just like these, so this would fit into one of these two categories, probably this one. So what we can do now is, now that we have these things separated out, we can make predictions about substances. The point of all this is so we know if we're using a material, what it's good at. Do we want a material to like make a statue out of that's made out of this? Copper sulfate? Probably not. It's going to get rained on and dissolve. So we have to know about these properties. Alright, the making sense. They asked about a sports drink. So if we took a sports drink, we test it, dissolved in water, and it is a good conductor. So where do we think, or what conclusions can we make about that? So if we look at it, it dissolved in water and it conducted, so I'll put a sports drink in that category. So like Gatorade. What are the things in Gatorade they advertise that they have? Or think about the logo of Gatorade, and what does it have? Gatorade is like that. It's a lightning bolt. They're advertising the electricity. They have the electrolyte. If you look on their website, they'll say electrolytes fight dehydration with 110 milligrams of sodium and 30 milligrams of potassium per 8-ounce serving. So they're advertising they have sodium and potassium. What does sodium and potassium do? I don't know, but it sounds good, and that guy was really sweaty, and he looked athletic, so I'm going to drink this stuff. But the electrolyte, basically an electrolyte is an ion. We know already an ion is an atom with a charge. So it doesn't have sodium in it, because that would explode. It has sodium ion in it. It doesn't have potassium in it, because that would explode even bigger. It has potassium ion. That's the stuff that when you sweat out, you need to replace. The electrolyte thing is really important too as far as conducting electricity. Your brain works by firing electrical signals. When you get tired and sweaty when you're in sports, you start to make bad decisions because your brain doesn't have the power to send those signals anymore. So you replenish it and you will perform better. Your muscles will work better too. So why do these things work out the way they do? We need to know a little bit about conducting and dissolving first. So to dissolve in water, particles have to interact with the water molecules. Water molecules are like little magnets. You have the positive end, you have a negative end. So some things don't care about the positive or negative. Some things do. So if there's another molecule with some positive and negative in it, if that thing comes along, if that thing comes along, it's going to interact with water in a certain way. That positive is going to be attracted to the negative of that. If you have something else without the positive and negative, it just doesn't care. That's like if you have a piece of styrofoam and a magnet, it doesn't matter. So we can see some examples of this. This is a sugar molecule. So All the sugar molecules in regular sugar and solid sugar are just there clumped up together. As water comes up, it's able to break apart because the sugar has all these positive and negative areas on it that the water is able to interact with. And so the water will surround a piece of sugar, a molecule of sugar, and separate it out. So if you watch a sugar cube, if you put it in some hot water, you should go do that and watch it and come back. Hey, that was neat, wasn't it? So the sugar cube will just eat away at itself, or the water eats away at it. It doesn't bond with it, it isn't combining. These are still their own separate molecules, but they surround it. You can also see it on a different type of atom. This would be salt instead of sugar. The difference between these, sugar didn't conduct when it was dissolved, salt does. So we'll look at the difference in these. So here, a molecule of salt is NaCl. Sugar molecules stayed together. The Na and the Cl are totally being broken apart, so it's a little bit different. So the water surrounds not an NaCl combined as a whole, it surrounds an Na and a Cl and an Na and Cl, and once it dissolves completely, the Na and the Cl are totally surrounded, and so now you have ions that float around. So Gatorade, if you want to make some cheap Gatorade, you can kind of just drink salt water. But they had very small amounts of sodium in them. Gatorade also has other stuff to help you out, but that's kind of what you're doing. You're replenishing these ions of salt. Don't take just salt water and say that Mr. Curran told you to do that, though. You probably won't get the right amount, and it will make you thirstier. Alright, so interacting with water, some molecules do, some don't. To conduct electricity, first off, you have to have charged particles. That's what electricity is based on. That's why electrolytes are charged. So that's why you have your sodium ions. Okay, ions are electrons. So electrons also would just be an electron that's free. The second thing, they need to be able to move through the material. So if I have some wire, if I put in a bunch of electricity, I can't draw lightning bolts. That looks like it's missing there. I don't know. We'll call that a lightning bolt. So I put in some electricity. I put in some negative charges traveling this way. So if I put in some negatives over here, these negatives that are in the material are going to flow, no, the negatives are going to flow this way. So what do I have? I have charged particles, I have negatives. The negatives are able to move freely in order to keep that electricity going. Or if we look at it as things dissolved in water, I have a beaker. I put my probe in with my electricity. I have another probe coming out. In between them, I have a light bulb. If I want that to light up, I need electricity to flow through here. So in order for electricity to flow, if this is the negative end of it, I need these negative particles to be able to start to move. So as these negatives flow from one end to the other, that flow from there to there is what makes the electricity able to light up the bulb. I'm missing a battery. Ignore that. So, charged particles moving freely. Now, if we look back at what we had earlier, our different types of substances, the ones that conduct look like this. The gray area, that's the electrons. So we have negatives and positives, negatives and positives. These are ones that dissolve. Why does it dissolve? These negatives and positives interact with the water magnets. So the water is able to interact with those and then break them apart. The other ones that dissolved were these. So that would be like sugar and water. So a water molecule, this one's a little bit more positive, that one's a little bit more negative. A water molecule will be able to break that off and then surround each of these. So this guy is able to separate out and float around wherever he wants to. If we compare that to the metals, that's all negative all throughout there. The insides are a little bit positive, but it's not in a way that allows the water molecules. If this is all negative, all of it's attracted to the water, so it doesn't really matter. It doesn't make a difference if everything's attracted. And on here, these are so bonded up that there's nothing that the water could really interact with. All of these gray areas, that's the electrons, they're so bonded that there's no positive or negative side. It's just all the same charge. So, why do these dissolve? They have positives and negatives, and they're able to be separated out. These are really similar to those. They're just linked up a lot more. And why would these conduct electricity? You need charged particles. They need to be able to move. So here, we had negatives and positives. They don't conduct when they're dry, because this guy could put in an electricity here, these negatives try and move, but this guy is stuck here because there's a positive holding it in place. And there's the positive, and there's the positive. The positives hold the negatives in place so they can't move anywhere. If you look at the metal, these negatives, these are all free to do whatever. So the electrons can move all over the place. If you look on your pink sheet, there's a description under each one. I'm going to go over now so you can read. There's a description of how the electrons are arranged. So like the metal, it's a sea of electrons. They move freely. So electrons can travel all over, and that lets electricity travel. If we look at the ones that don't conduct, the electrons are stuck right here. Even if you dissolve this, that's the bell. Even if you dissolve this, there aren't any charged particles. So no ions, and the electrons are stuck. On here, you'd have the sodium ion, the chlorine ion that are able to move.
So cold outside.
Alright, so the last one isn't going to conduct either because it has these electrons, but they're stuck in place. So just like the other one, electrons are stuck, no ions. So if I put some electricity in here, this guy tries to get away, but he can't go anywhere because those are holding on to it too much. There's all this linkage together of the electrons, so they're all stuck in place, can't get anywhere. So, why do things conduct and dissolve? It has to do with interacting with water molecules, and it has to do with charged particles that can move. So next time we'll finish up talking about this, make some sense out of it, and the type of bonds. Take care.